Anyway, welcome back, part 3. And just like to say nice welcome to Joel Webber from Full Story, who's had a flu in this morning, so maybe feeling a little bit jaded, right? Saving the beers for after his talk. So if you do questions at the end, don't make them too taxing. Anyway, so welcome to Joel. Give him a nice round of applause, and looking forward to your talk.
Yeah, if I pass out, just drag me down there and prop me up against the wall. It's been a long day. So I think this talk is usually a little bit longer, so I'm going to try and squeeze it in a bit tight, leave some room for questions at the end. So I'll go fairly quickly in breadth first. Very briefly, who am I? As I was just mentioned, I'm one of the co-founders of Full Story, which I will not plug at all, so feel free to ask me questions about it afterwards if you like, but I promise not to plug. In the past, I was at Google for about 7 years and worked on web toolkit there, so transpilers, that sort of thing, and briefly on Chrome itself. And had a nasty habit of porting games to the web because it was more fun than working on developer tools. So we did Angry Birds and Quake sort of publicly, and Minecraft at one point, but unfortunately you never got to see that. So that's the revenge of my reformed game developer roots. But it's led me to really care a lot about performance. Arguably, I kind of got to skip Web 1.0. I was working on mobile apps back in that era. So I've always viewed, I really got into the web as a platform after it was more like an application platform and less like a hypertext document store. So what I'd like to talk about is apps. And when I say web apps, I mean apps like you're treating the web as though it were an application platform, no different than Windows or the Mac or iOS or Android or anything of that nature. To be clear, that does not mean I am an app purist. I don't think that I think a lot of things should be pages. They work perfectly well that way. But there are cases where we are really building more and more very complex web apps. And that's really what I want to talk about. I'm also not going to talk a lot about, when we talk about web performance, a lot of times, to a lot of people, that really means how fast can I get my page to load? And that's really important. It's just not what I'm going to talk about. I'm concerned with what happens primarily after the page loads. And so really broadly, this is sort of a dense slide, but very broadly, what I want you to take away from this more than anything is that if you're building a web app, you are building an app. And I'm getting somewhat repetitive here. Point is, it's not this thing that we think of as Web 1.0. This is the pages, these apps that were built that way are roughly equivalent to VT100 apps from the 60s. That was great and all, but when you look at the life cycle of a web app, of a single page web app, it is pretty much identical to a native app. The pieces are slightly different. We call them different things, but ultimately they're basically the same thing. And what that means is that you need the tools that we have the kinds of tools we've always used to make web apps performant or to make native apps performant. You need a lot of data. They're very complex. In some cases, they're more complex than a lot of traditional native apps. Brief detour. Loading web apps still is important. So I said I wasn't going to talk about the load time issues, but it is important to know that there are a lot of good tools for measuring performance, measuring startup performance, measuring load times. I just wanted to mention them briefly so that you're aware in case you're not. Google's PageSpeed, Lighthouse, tools for measuring progressive web apps. I'll put links at the end of the slides if anyone wants to look into these things. So it's not that load performance doesn't matter for native apps, or for web apps, I should say, but rather that it's only a very small part of the picture. So a couple things that can really come out when you're talking about a native app, or sorry, web app, is that a lot of traditional metrics just don't work anymore. So what does it mean to say a document's loaded, like DOM content loaded? What does that event mean in a web app, in a single page app? Usually it doesn't mean anything except the shell has loaded and you're actually starting maybe to execute some script. You care a lot more about how fast can the user get from 0 to interaction, and as a waypoint along that path, how fast do they get from 0 to something useful on the screen. So there's 0 useful stuff on the screen, and I'm actually able to interact with it. But the traditional metrics don't really matter for that. Onload either fires really early because you didn't load anything statically, or it files really late because you had a bunch of preloading going on. And in fact, this is Google Inbox, I believe, about the time that the load event fires. So if you were a user of this, do you think that, is that loaded? I mean, not by any reasonable metric that I can think of. But this is pretty typical, right? So, you know, and depending on, I'll come back to first meaningful paint, what that really means, but you know, this is pretty typical. So you're going to have to measure this yourself. You're going to have to decide what it means for your app to really be loaded. And in most cases, that means you have to define it in your app code, because the browser can't really tell you because it doesn't know. In some cases, this would be first meaningful paint, but it's kind of a heuristic, so it's really hard to be sure. I'll come back to how you can get those measurements from the tools. So once an app's loaded and running, what are the numbers we care about? These are some of these are based on, some of these are just strictly true. Some of them are kind of heuristics. I'll work backwards. If anything takes more than 5 to 10 seconds, you're just going to go off to Facebook. They're just going to give up. This thing's taking forever to load. I'm not doing anything here. If it takes longer than about 1 second, let's say opening an email in Gmail or something like that, it's just going to feel slow. That's just, you know, I think we all have a pretty natural intuition for this. We also know local interactions, that is like the time between the time that I press the button on my mouse and a button depresses, or any other sort of quick local interaction. Anything over about 100 milliseconds feels like it's lagging, it's behind, something's not right. And then this last one, this really tight number, which really matters, is 17 milliseconds. So that's basically, it's really 16.6 repeating. It's 1/60. That is to say, in any interaction that is rendering performance level, that is a scroll or animation, you've got a tiny 17 milliseconds to do anything you're doing in there. Practically speaking, it's even less than that, right? Because if you take 17 milliseconds, there's a pretty good chance you're going to cause the renderer to skip a frame, and it will drop quickly from 60 frames to 30 frames a second. And for any gamers in the room, I think we kind of know what that feels like in practice, right? So that's our goal. As tight a loop as possible in any interaction that happens within a single page app. Okay, so what are the resources that apply here? Obviously, the most precious resource is your user's time. If you're taking 10 seconds to load an email, a report, draw a graph, whatever, you know, that's awful. You don't want to do that. The parts that make that up, obviously, these are not surprising, but they're important to keep in mind. Obviously, CPU time. How much time are you spending sitting on the CPU? GPU times is a little bit subtle, but it matters a lot for those rendering interactions. Like how much time is spent compositing, and I'll come back and define that term in a minute for anybody who's not familiar. But the time you spend on the GPU is it's kind of implicit. It's tricky to understand how you're getting there, but there are actually some good tools for understanding this now. Obviously, memory, and memory is a little confusing because you say, well, for me, as long as I have enough memory, it should be fine, right? It's not going to slow things down. That's not strictly true, because you end up with GC interactions and things like that. A lot of depending on how you're using the memory, how much memory you're using and how you're using it, whether you're touching it, it translates into CPU time for garbage collection and just your own algorithms. And then obviously bandwidth. So if you abuse the network connection, then you will eventually slow things down. There's also subtle aspects to this as well. For bandwidth, there's also things like request slots. Is people generally familiar with the idea of a fixed number of request slots available? So right, if I fire off 100 HTTP requests out of all the bandwidth in the world, half of them are going to get stuck waiting. So there's a lot of opportunities to optimize things there, and especially those sort of non-local interactions like network requests, action, network request response can get really slow if you're not careful about the way you use those request slots. So relatedly, and unsurprisingly, I think I mentioned some of this already. So where does our time go? Obviously, loading data and resources over the network or local file system or wherever you're getting them. And most of the CPU time will be JavaScript execution, except for garbage collection and rendering. So JavaScript execution obviously is your opportunity to create some really seriously slow stuff if you're not careful. But there are some really subtle, I think people who debugged, spent much time debugging complex local rendering, rendering of complex UIs, have run into a lot of these things. And I'm kind of glossing over them now, but I'll come back to them when we get into the tools. Obviously, things like style recalculation, layout, and then rasterization and compositing. Where rasterization really just means getting pixels into buffers so that compositing can put them actually on the screen. And again, I'll come back to that in a minute. But these things can be really subtle, but they will eat a lot of your time, either CPU or GPU time, if you're not careful. And then, of course, there are things that take space. And again, there's always this trade-off, or I should say this almost translation. And things that take a lot of space eventually end up taking a lot of time for various reasons. Documents, translate that to frames, really. Large numbers of documents, large numbers of frames can get pretty expensive. Large numbers of DOM nodes. We deal with third-party web apps, and I have seen everything from a couple of thousand to like 100,000 DOM nodes. That stuff creating large numbers of DOM nodes makes everything much more expensive. But sometimes it's easy to just create a lot of them for unintentional reasons. Obviously, the size of your JavaScript heap goes back to the question about garbage collection in particular. And we'll look at some patterns around that. Images, I mean, it's a little bit subtle, but using a lot of images, a lot of high resolution images can get really slow. For memory bandwidth issues, for reasons, for garbage collection, obviously, just memory thrashing in general. And then GPU memory. It's a subtle one, but there are a lot of clever things you can do that make animations run quickly, for example. Creating large numbers of CSS animations with clever transform tricks. But those things start to allocate a lot of space in the GPU. So you'll see, I'll point here. Everyone here familiar with the Task Manager in Chrome? I'm referencing Chrome. There are equivalents in Firefox and Safari and so forth of these, but they're the ones I'm most familiar with. This GPU process, that can start to consume a lot of memory. Those are all off-screen. Those are all buffers. Those are just the CPU side of the buffer. You're not even seeing the GPU half of it in this measurement. So if you have a lot of clever animations going on with transforms and things, that'll start to go up a lot. And there's actually a lot of contention for bus bandwidth, right? Because every time I update a buffer, I render something that goes into let's say a div that has like a 3D transform applied to it. Not only does it have to render the thing, but it's got to transfer the actual pixels over the bus and onto the GPU, and that stuff all takes time. So those are the major, the basic moving parts we need to care about. It's a quick detour. Or who here is familiar with the way that? Broad show of hands. Who are familiar with the way that Chrome and other multi-process browsers are broken down into pieces? Okay, small number. Good. I'm not wasting everyone's time. Hopefully. So basically, what you're used to thinking of as your tab. In Chrome, they call it the render process. I'm not sure what it's called in others. This is where all the sort of traditional stuff you're used to thinking of as a browser actually happens. HTML and DOM, HTML parsing and management of the DOM, JavaScript execution, style recalculation and layout, and so forth. And it used to be rasterization as well. That all happened locally, but now that's mostly been moved off to what's called the compositor process, which is handling, getting pixels into GPU buffers so that they can be rendered on the screen. And then finally, browser process kind of manages it all, and it mitigates all disk I/O and I didn't put it on there, but network interactions and things like that. And this matters for the purpose of understanding really how pixels get to the screen, because that's by far the most expensive thing that a browser does most of the time, is working from HTML, the DOM structure that's in memory, getting that translated into pixels onto the screen is by far the most expensive things it does. Okay. Anyone here ever seen the Chrome FPS meter? No? Okay, feel it's good. I'm on a bit of a mission to remove what I called jank. That was a term that I first heard on the Chrome team. It's when things feel weird and hitchy, like you're scrolling and somebody does something weird in a scroll handler and the thing kind of hitches as you're scrolling through it, or animations hitch, things like that. The browser has all the tools and ability and performance to behave just as well as any iOS app or anything like that, even better on a desktop. But it's really easy to cause things to hitch. And give you an idea, we have it on here. And this is an unusual thing to demo as a web app, but I used it to make the point that these are just as complex as any native app. In fact, let's just play Quake for a second. Can we see? I don't know, that FPS meter is really small. Apologies there. But you notice that it was really hitchy for a while there because it's loading resources, and most of this port was hacked to death. So there's nothing's offloaded to separate threads or anything like that. But I mean, this is, now you can see there's a solid flat line up there with rounding error that is 60 frames a second. And, I can run around shooting things and so forth and getting into trouble. I won't waste too much of your time with this. But it's also really hard to play with a trackpad, let me tell you. So, but think for a minute, like, what is this doing, right? It's a solid 60 frames a second. This is great. Let's try not to get killed here. It is doing, and this is really that 17 milliseconds. It's having to squeeze tiny bits of, into tiny spaces, an enormous amount of computation. And just to give you an idea, hold on, let me redo this. Okay, and this is the main thing I want to show you. I'm probably going to run up into a time wall fairly quickly, so I'm going to go the best I can to get through this. Get killed here. Okay, so quick show of hands. How many people here have used this particular tab in the Chrome DevTools? All right, thank God. It's like double the last time I did this talk. So I don't know if you can recognize this, but this is where the Chrome team is clearly moving all of their tools. So we've got, in the past, we've had the profile, the standard like JavaScript profile, where you get a sampling profile over all the JavaScript execution for like 5 seconds. Well, that's great, except for there's a million things that happen over that 5 seconds. Which one do I care about? Oh, I got, this one thing is a super hot spot. The network graph is kind of the same way. The network graph is just network stuff. The network graph is, it's useful in some circumstances, but I really love this view. Now, the downside, I know no one can barely read anything that's on the screen right now, but the downside is this was basically, a couple of years ago, this was basically internal debug tools that the Chrome team had hidden behind the Chrome internals tab. And it shows, it looks exactly like it was designed by the engineers that it was designed by. So, but if you're willing to spend some time with it, there is an enormous wealth of information in here. So just delve in for a moment. So, and I'll zoom in on some stuff here to make it clear. So I had this thing actually recording rendered frames. And I'm going to zoom in here. Oh, I think I've made the Chrome DevTools perform badly. Okay, there we go. Okay. So now imagine translating this to, let's say you're tracing through a janky scroll interaction, like on your app. It's getting weird hitches while network data is coming back or something. Maybe it's template renderer that's behaving oddly. Really amazing is you can sit here and go over these frames. Which frame what would it render? Okay, hold on. There's a spot here. Let me drill down into this. Let me close the frames so we can see. And is that zooming there? Good. I love the accessibility tools on a Mac. Okay, so here we go. Animation frame. Oh, that's really useful. That's the request animation frame callback, right? Because this is obviously built to run at 60 frames a second, so we use request animation frame. And then you have these nice little breakdowns of all the things, and you can zoom in if you have to. Okay, there's the frame renderer. These names are all horrible because they came for the original C code we ported, but okay, predict movement. Oh, wow, that's one. Okay, that's 2 milliseconds. There's a hull check. I mean, you get the idea, but okay, update screen, it's 2 milliseconds. This whole thing, what did we spend? We spent 5 milliseconds total across the entire thing. So it's really nicely targeted breakdowns of where your times are really going. So when you have, for example, you think maybe your problem is script, you can find it really quickly. You can see the sort of the dominator trees of the way the time is divvied up against different, various things. Oh, there's one. Okay, can you see that? Yeah, okay, that one was really fast. But on a web app with a really complex frame interactions, really complex animations and things like that, this composite layer, you'll see there's this big complicated layer tree that is compositing on the GPU. That can get really slow in some circumstances. So in fact, I think, is that the one? Oh no, hold on. So I'm getting a little ahead of myself because I'm trying to optimize for time here. But if you zoom all the way back out, you can kind of get a pretty clear view of what's going on. Hold on. Apologies while I reorient myself. Okay, well, we just saw all that. Yeah, so this is just a little higher level breakdown. So obviously, each one of these things gives you this detailed view on the bottom that lets you see. This is the stuff you would usually expect to see in the old what do you call it, in the old profile graph, except that now it's limited to the exact same thing you care about. In this case, a chunk of, I don't know, did I do that correctly? Yeah, in that case, it's a chunk of jQuery code. But knowing exactly which event triggered, which user interaction, which event triggered the particular call graph that you're seeing here is really, really helpful. And you can also see, I'm going to go back to this thing at the top. So this is a breakdown of, so there's this high level graph at the top, which is really useful for orienting yourself. And as you can tell, it's a complete fire hose of data. So being able to see a really high level what happened during this interaction, that's referring to all of this stuff up here. So up here in this green here, we've got this is frame rate. Higher is better. So if it just stays at the top, it's 60 frames a second. If it dips, it's bad. You get a general idea of times the orange is script interactions and so forth. And I'm not going to go into great detail on this. You can figure it out by just hovering on things and kind of playing around with it. But and when you have, in fact, I'm going to do something. I'm going to reload this. This is really useful for checking load times, by the way. Click on that little refresh right there, and it will refresh. Okay, we'll catch all these and start profiling. And then you go over there when you're ready. Oops. Oh, well. Oh, it stopped early. I think it does that sometimes. But here, what do we have here? Let's see. Right here, for example, you can see, oops. It's doing things like annotating slow interactions. So you can see the frame rate is essentially 0 here while the frames are this blackness because it's doing an enormous amount of computation in the background. You start to see all the network interlaid in here. So there's all various network requests. You can get a little more data from the network tab, but most of the time when you're trying to compare all of these interactions, okay, the user did this, clicked on this, we fetched that, we did this JavaScript execution, we triggered this layout. All of those things being co-located makes it a lot easier to follow what's going on. And you'll see things like compositing, update the layer tree, that's more GPU stuff, recalculate styles. And in a more traditional web app, you'll see a lot more of that kind of interaction. Let's see. Oh, and also, yeah, I'll use this as a reference because that one didn't have a good example, but you'll see these lines on here. So first meaningful paint, DOM content loaded, the actual load event firing. This graph is great for understanding, even though I'm not trying to talk primarily about load times, it is great for understanding where those things happen, especially when you couple it with a frame graph. So you say, for example, the browser said, I think the first meaningful paint, which is entirely heuristic, happened at about 800 milliseconds. Well, what did the frame look like? Well, you can tell exactly what that was. It really helps for drilling down on whether the heuristics you're using, first meaningful paint, load, DOM content, and so forth, are actually what you needed them to be, which is great for those kinds of forensics. Let's see. I went into this a little bit. Again, this is the network graph bit. Again, a little less data than the network graph, but you can always go back and get the network graph, the actual core network with headers and all that sort of thing elsewhere. But here it actually makes it easier to tell what interactions are causing the network requests. You can usually tell what other things are lining up on the other side of it. So for example, If you've got a long-running network request and the frame doesn't change, you can see in the frame renderings all that time, then chances are that network request was the long pole in the tent, stopping it from rendering. That often is very difficult to tell by just looking at the network graph. Like exactly when did that thing come back and render? This makes it a lot clearer. Let's see, what else? Obviously interactions. It's pretty, I mean, anyone who's used the tools has probably seen this, but again, being able to drill into each one of these things, see what scripts got triggered by a particular interaction, drill into the call trees and so forth. And let's see. I said earlier that I was going to talk a little bit about these things. Just suffice it to say, if you know what style calculation layout, JavaScript execution, et cetera, are, these are things that are, without these tools, is very difficult to tell when you've done something that, for example, you just made one tiny little change to, I don't know, a style on, or a class name on the document body, but it triggered 370 milliseconds of style recalculation. Those kinds of things are actually not uncommon. These tools make it a lot easier to find that. And oftentimes you'll find things where you said, I thought it felt kind of janky, but I guess I sort of thought it was okay. But when you look at it and you see this big spot where the browser was obviously hung for a few hundred milliseconds, it's kind of hard to look away from it once you've seen that. Whereas when you're in a hurry and trying to ship something, it's really easy to go, I think it feels pretty good. But in practice, it could be a lot faster, a lot smoother. Let's see. Oh yeah, I didn't get a good example of this, but when you are looking at the frame view, this thing down here, this is a weird little 3D rendering of what the layer tree looks like. If you're doing stuff, it's just called layers on that bottom tab. If you're doing stuff with complex animations and things of that nature, then you definitely want to pay attention to this, because if things are getting weird, you can often see that Chrome decided to split up into like 100 layers, and all of a sudden you're contending for GPU bandwidth, bus bandwidth to the GPU. So that's obviously important to pay attention to as well. Comes up in a lot in like complex animations during scrolling interactions, things like that. Let's see. How are we on time, by the way? Okay. Wanted to leave room for a little discussion. On memory, let's see. I think this one actually, I think shows a pretty good. Oh, wait, no, hold on. Yeah, this will. Okay. I'm just going to record a few frames here. Well, it locked up. Sorry. Apologies. Just wanted to show a little bit about what the memory interactions look like in the wild. Let it load in. Render a few frames. Okay, yeah, here's a perfect example. This is sort of a classic Sawtooth Network memory allocation graph. This isn't actually too bad. It's these blue lines going up here. Let's see, yeah, so this is going from 134 megs on the heap to 145 or so, 146. Then obviously there's GC right here. So there's garbage collection. And this isn't that bad. I mean, it's just, 5, 10%. It's not terrible. But oftentimes you'll see these huge sawtooths, and there will be huge hits when there's a big GC. If you're doing this, you're allocating a lot of memory. In this case, it's allocating a lot of memory for each frame, kind of throwing away a lot of temporary objects. Chrome's gotten really good about this. Some browsers are not quite so good about doing incremental garbage collection and so forth. But every once in a while, you'll see one of these sawtooths where it's just one tooth because it doesn't end, and that there's your memory leak, right? This graph view makes a memory leak glaringly obvious. You can't miss it, and oftentimes those things go unnoticed when you're just testing. Right? So you app, get it going, test it for a couple of minutes, everything seems good. Then your users get it in the wild, and they're like, this thing just gets slower and slower and slower, and what's going on? Eventually, the tab just crashes. Usually, very, very often, that's going to be a memory leak, and you'll see it in that form. Same thing, this isn't a good example for this app because there's only one DOM node in the entire thing. But you'll see this green line is DOM nodes, Well, okay, there's 590. I'm not sure why there are 590. Oh, fake images, that's why. Okay, at any rate, you'll see the memory leak of DOM nodes is even more insidious. So those things, if you get a bunch of DOM nodes pinned, then not only is it consuming a bunch of memory, but the browser is running algorithms that are order DOM nodes all the time. Style recalculation, the render tree handling, all that sort of thing. So if you're leaking DOM nodes, I've seen this in the wild surprisingly often, you will drag that thing to a halt really fast. So it's again, these are great tools for letting you know about that before your customers start bitching at you rather than after. Let's see, what else? Oh, real quick, things you should know about. If you're using these tools, I did not know about these until fairly recently, but there's a TimelineMark API. So I think it's performance.mark measure. I think you can look it up. I put a link in the end of the slides. But this is an example, like React in developer mode automatically adds all of these extra markers on the timeline. This is phenomenally useful if you're willing to put in the effort, because you can put alongside all the other events, the user interaction events, performance events, JavaScript, et cetera, your own application specific values, which is really useful. You can say, okay, this is the part where we're rendering the template. Okay, now all the JavaScript execution and so forth will be underneath that, which allows you to place blame where it's deserved a lot more effectively. And again, some more and more libraries like React are starting to do this automatically. Let's see. Really briefly, there's some stuff if you're wanting to do some more stuff programmatically to capture data in the wild. Again, an API that I find a lot of people are not familiar with. Who has ever used a performance object? Performance dot, et cetera. Oh, surprisingly large number. This is a really great little treasure trove of data for capturing data in the wild. So you get things like, most of it's about resource loading and initial rendering, and initial page load. But this is still really, really useful data to have. So things like, okay, here's everything you ever wanted to know about what it took to load that JPEG, or here's the time for the first paint or first meaningful paint. There are a few others. I think they're adding more into the spec. It's a little bit manually and labor intensive to do that by hand. But anybody here familiar with the term real user monitoring, RUM tools? Yeah, it's a great class of tools. And I've always had this theory that there are a lot of tools for measuring in the lab. In fact, it's what we were just looking at. Sort of, you've got it on the workbench, you've got it under a microscope, but in the wild, you never know what's really going to happen in practice. So the RUM class of tools is getting a lot better about utilizing everything they can to tell you when your app's slow to load, slow to render, slow network requests, that sort of thing. You can't get as much data, but you'll get a lot more realistic data. And in the wild, I mean, we've all shipped web apps here. We all know that in the wild, whatever you expect things to happen, whatever things you expect to happen, they won't ever actually turn out that way. So while you may not have quite as much data, you can use that to generate hypotheses about why your app's behaving badly in Slovenia or what have you, and then put it under the microscope and then really pin down what's happening. But until you have something to generate those hypotheses, you don't know that something's wrong until you know it's wrong. You need data first. So that's a really really useful class of tools. And ultimately, you end up back in the Chrome Dev tools trying to pin down the details. But you need to know that something's going wrong in the first place. Okay, I said no plugs. Tiny plug. Again, I won't go into detail at all about full story, but suffice it to say that we are starting to implement some of these RUM features. It's not a RUM product really in and of itself, but we are trying to grab a lot more of that data in the wild as much as we can to couple it with session recording, so that you can see a combination of user behavior coupled with performance related data using a lot of those same tools. And I think that's about it. Hope that wasn't too fast. I tried to leave a little time for questions. And with that, I think it's time for questions.
Okay, it's right first at the front.
I was curious how you think Chrome DevTools, specifically for performance, compares to Firefox DevTools, because in a lot of areas, Firefox DevTools are now, in my opinion, better.
Right.
I don't know that much about the performance side of things, so.
Yeah. So first, I have to confess a certain degree of ignorance on the subject. I tend to use the Chrome DevTools more when I'm trying to debug something really complicated. I found that the last time I checked, and I think it was about the last time I checked was probably the first release of Quantum. Firefox had a lot of really great tools for designers that Chrome and Safari don't have at all, and those are great. I love them. But it tended to fall apart on really complex apps or really complex scenarios. Just get really slow sometimes. I think they're putting a lot of work into that. So it tends to be, if I have more of a designy sort of problem, then I'm much more likely to go to Firefox. If I have a much more like performance at scale problem, like this app is just collapsing in a heap of rubble when they put 8,000 things in the inbox or whatever, then I tend to be on the Chrome side because it tends to hold up a little better. Now, occasionally they'll all go down in flames, but I get a little further with Chrome usually. So it kind of depends on the use case in my experience.
Hi. If you're working on something that lives in the browser with someone else's code, like the full story client, for example, so you're sitting in page with someone else's application.
Yes.
Have you got any ways of sort of instrumenting the marginal effect on the performance of that page that the presence of your third-party JavaScript is actually having on the application?
Yeah. So did everybody hear the question? Okay. It's tricky. So we spend, with full story in particular, and this would be true of almost anything where you've got code that's going to coexist with other code in the browser. And let's keep correctness aside for the moment, because that's already hard enough. But when it comes to performance, we spend a lot of time building up. We have a test infrastructure that basically uses a few different browsers. We're trying to expand that set and runs through. We sort of get common cases kind of in a jar so that we can get them in a test framework. And then we're still doing this by hand right now. But do this interaction with, do it without. Look at the JavaScript traces, and now that's imperfect, but it's about the best we have right now. You can at least measure course performance. So just, was it 5% faster? I mean, slower, or 1%, 5%, 10%? And then you can measure fine grain, like, okay, which interactions are actually causing these problems. That's where again, those interactions in particular, that on that performance timeline come in really handy, because a lot of the time, something that over the course of say 1 second washes out turns out to be not evenly distributed at all. So if you can say instead, here's a user interaction, here's a DOM mutation. Now here's the part where, let's say, full story kicked in and started snapshotting the DOM. We come up with some thresholds, like if it took 100 milliseconds to make the original change, we'd like it to take less than 10 to do the recording. Something that I'm making that number up, but that's the general idea. Automating that is still a giant pain in the ass, because the dev tools, there are APIs for interaction with the dev tools, but they're pretty obscure and they don't really give you that much detail. So our goal is to get into a place where we can automate that process so that it's just part of the CI. Here are our cases, here are performance bounds that are acceptable, and alarm bells will go off if we ever commit any code that would degrade that. That said, it's always sort of a game of whack-a-mole, right? There's always this long tail of cases you never thought about, which is the joy of making code interact in JavaScript, right?
Sorry. Swallow my beer. Unfortunately, it's not. I was just going to say, so I've done a lot of front-end development, and I'm sort of front-end lead in this. I've just, a lot of our clients have started paying a lot more attention to performance. That's something that I've, in the last couple of months, been doing a lot of research into, studying, trying to teach myself. Is there any recommendations you could make, except for doing 7 years at Google, that could get...
I haven't learned that much in 7 years.
That could get us to understand a lot of that as quickly as possible, because I think it's phenomenal
Right.
I definitely want to implement it, but I'm doing a lot of reading, a lot of going through the Google documentation, etc. Is there any other way that you could recommend, or how would you recommend that some of us
Right.
could get it to that state?
I'd say a couple of things. One, I'm really glad to hear that people are caring more about performance, because I think we're all probably getting sick of seeing web pages that perform atrociously. So that I'm very, very glad to hear that. Right. Well, I mean, that's, those two, they're just flip sides of the coin. They both matter, but it's, I focus on this just because it gets so little airtime. So please, anyone correct me if I'm wrong. I'm not aware of any really good books on the subject, or really even blogs or anything, because it's just not a topic that gets a lot of attention. What I would say is, if you work backwards from a goal, just take a real world site, just go to, God forbid, Yahoo or something, and see, or something. Next time, I do this actually as a hobby, because I'm a really, really dull person. Next time you see a website that's behaving strangely because of some terrible pile of ad tech in it or something like that, they're polling for viewport intersections every 200 milliseconds and cratering your CPU. Get it under the microscope. Just start playing with those tools. It's really daunting at first, but it only takes an hour or two to really get a sense for what all the moving parts are, and you'll start to see the same patterns in your own work. At the end of the day, it's really just about the user interactions, rendering times, and the frame rendering update loop. I mean, those are really, and the network requests. I mean, those are really the only things that matter. So all the complexity in that stuff is really just all around those things. And so you'll find horrific patterns really quickly. And almost, just go to any sort of long tail content site that's got giant piles of ads all over it. You'll find some horrific things, and it's kind of entertaining in its own right. You'll also learn things you want to block because they're really annoying. But I mean, just getting it under the microscope in the wild is by far the quickest tutor in my experience.
Well, I would say keep coming to this meetup,
Or
right?
that.
Keep meeting all these fellow compatriots that were in the room, and of course, come to Delta V, right? And that will give you a great education. I mean, some of us in the room, I mean, I've been involved in this meetup since, oh God, 2010, something like that. I don't know half of this stuff. All right. So you just keep learning, keep talking. And there's a really great little performance community here in London. Use it. Any more questions? We'll do one more, if that's okay. You can all have talk over the pizza stuff, otherwise it'll be stone cold.
I thought I smelled something.
We're full story users. For me,
Thank you.
run metrics is quite an exciting topic to go with full story, because I feel like a lot of the run tools out there at the moment are very obviously missing out things like UX,
Right.
which you really want to tie to performance.
Yeah, context is hard.
Yeah. So how much time are full story going to spend kind of making run part of full story more in the future, or is it just a sideline?
No, it's a big deal. I literally have 3 branches out on my laptop right now, right in here, for things that I'm supposed to commit this week while I'm here in London. Kind of bad timing, but yeah. So, I mean, when you think about it, there's so much stuff in there. So I can give you this. I'm kind of tipping our hand a little bit, but I don't mind. A couple of things out of the gate. So obviously, everything you can get about performance, network performance. So page load times, rendering times, network performance, all successful requests at least. Errors whenever we can get them, so XHR errors, things like that. Then I'm thinking off the top of my head. I'm really happy about this. I came up with what I think is a clever way to detect jank. So basically, if your frame rate drops below 60 frames a second for more than some heuristic period of time, we can detect that. So we're trying to win that in, not to really create like a RUM suite. There are tools for that sort of thing. They're great for what they're for. They serve their purpose. But rather to provide as much context as we can for the actual session recording, so that you can say, for example, is there a correlation between slow page load times and users, I don't know, rage clicking or having this an issue navigating from, to the next step of a process or what have you. Then you can actually dig in and see, okay, oh, there they are waiting on it. Here they are getting really pissed off at me. Here they are not completing, not completing the funnel or what have you. But we're going to try and do it as much our own way as possible. So it's all about context and being able to drill down to the details of the actual interactions. That said, if you have things you would like to have, pin me down afterwards and tell me. That's at least triples the probability we'll actually do it.
Okay, right. Well, thank you very much, Joel, for that
Thank you.
talk. Right, give Joel another nice send off after a very, very long day. Right. And